I told you when I think about ray optics that it is the study of the some phenomena of light. So the light exhibit different phenomena. I named it as a reflection, refraction, and scattering dispersion. Among which, now let us discuss about refraction. And for this year, we are not going to discuss about the reflection. So let us discuss about refraction. Yes. Refraction. So this is a kind of phenomena which is exhibited by the light. So this phenomena we can also see in our nature. We can see this process during the sunrise and sunset. What happens is we see sun actually before the sunrise. Sometimes what happens is we see the sun actually it is before the sunrise. Sometimes what happens is we see the sun actually even after the sunset. Sun is already being set, still we see the sun. This happens because of the process called refraction. So it is a phenomena exhibited by the sun. By the light. So about this phenomenon, a scientist called Snell has experimented. He done experiment on this phenomenon of light, and he has got some results, and he stated such results as this law. So Snell has given a law for the refraction. So that is why those laws are very famous as a Snell's law. So let us understand what a refraction is. So for the better understanding of this concept, I am using the animation.
This is the animation page, and in this animation page we can see some of the things. We can see some colored regions, we can see a line, we can see some source, some object here. And before experimenting this, let us try to know what these are the objects. Initially we should understand what this white region and what this blue region represents. See, these two regions represents two mediums. Then what are the mediums? Can we give any examples for medium? Yes. As an example, we can take air, water, glass, oil. These are the examples for medium. So to experiment this phenomena, we need two mediums. What is the phenomena here? It is a refraction, and this experiment is done by Snell. So whatever the result he got from his experiment is stated as his laws. So that is why this law is also called Snell's law of refraction. Yes. So as an example, let us say the white region is a air medium, the blue region is a water medium. So to undergo this refraction, we need two mediums, and the light has to pass from one medium into the another medium. So to undergo this refraction, the light has to pass from one medium into the another medium. And you are watching on the screen there is a light source. It is actually a torch. If I push the switch, a ray of light will come out of that source and it will fall on interface of the two medium. What is interface? It is a layer which separates these two mediums. It is called as a interface of the two medium. So here we can adjust the position of this light source. See, I can vary the position of this light source as our requirement. So if you press the switch, light will come out of it. See, I can vary the its direction, and still the light is incidenting only at this point. See here, this is E. At this point light is incidenting, so this is called as a point of incidence. At this point light is incidenting to this. Okay, so we have to draw a normal to this point of incidence, because by drawing the normal we can measure some of the angles. So the use of drawing normal is to measure angle of to measure the angles. So we have to draw this normal always to the point of incidence. See, this is the point of incidence at which we should draw a normal. Let's draw. See here, dotted line which indicates the normal which I drawn to the point of incidence. This is the point of incidence. Now let us incident a ray of light. See, we are incidenting the ray of light. As we incident the ray of light to the point of incidence, we can see two rays. One ray which is a dull in color, another one is in a bright in color. So what is the indication? See here. So when the ray of light is incidenting on the interface of the two media, what will happen is, if the mediums are transparent, see, I consider a water medium which is a very transparent. So when it is incident on such a transparent medium, a part of light will be get back or come back into the same medium. See, this is a air medium. So to the same medium a ray of light is coming back after striking the interface of the two medium. So this ray will strikes on it and a part of it will come back to the same medium, and the remaining part will passes on into the another medium. So this is a passed light. This is a ray which came back to the same medium. So this ray, the ray which came back to the same medium, can be called as a reflected light. It can be called as a reflected light, a light which get back after striking a surface. A light which come back after striking a surface is called reflection. So this is a reflected ray. And a light which passes into another medium, and it has to move from one medium to another. So the direction of ray changed. See, actually the direction should be this way. See, this is the actual direction. If the both are the air medium, then the light will pass like this. But if I introduced water medium, the direction of light changes. So this phenomena is called as a refraction. So the direction of this light changes as it moves from one medium to the another. This process is called as a refraction, and this is done by scientist Snell. And this ray is called as a refracted ray. The ray which is in the another medium when a ray travels from one medium to another. Okay, so this is the incident ray, this is the reflected ray, this is the refracted ray. Okay, Now let's see by what happens by changing the position of this source. See here. See, you cannot see reflected and refracted light along this direction, and if I vary like this, these directions of these lines, reflected and refracted lines or refracted rays, also changes. So by what angle it changes? And we can also think here that at what angle we are incidenting this incident ray, at what angle this refracted ray is refracting, and also we can calculate by what angle this ray is reflecting. So to calculate or measure these angles, we have drawn this normal. So let us try to find the angle by placing protractor. See, this is a protractor. I am placing like this. Zero of this protractor should coincide the normal. Now I placed here. Now you can see the angles here. See, let me vary like this. Very beautiful. See, what is the angle? See here, this is the 31, right? 30. So this is the incident ray. So angle of incidence, right? A ray is incidenting at an angle of 30 degree. That angle is called as a angle of incidence. How did we measure? How did we measure? See, this is the normal from which we are measuring the angle. Okay. So the angle between this normal and this incident ray direction is called as angle of incidence. So angle of incidence here is, this angle is 30 degree. And look at this, this is the reflected ray. Look at the reflected ray. That reflected ray is also making an angle of how much? 30. So this is the angle. See, from normal we have to measure the angle. So angle of reflection is also 30 degree. But look at here, this is the refracted ray. So the refracted ray making an angle of 20 degrees. See, 0, 5, 10, 15, 20. So this refracted ray making an angle of 20 degree, and so the angle of refraction, this is angle, see, this is angle, that is equal to 20 degree, which is less than this angle of incidence. Angle of incidence is 30 degree, angle of refraction is 20 degree. So we can define the angle of incidence, angle of refraction. Angle of incidence means it is the angle between this normal and the incident ray direction. Angle of refraction means it is the angle between this normal and this refracted ray. Yes. Now here we observed a phenomena that angle of incidence is equal to the angle of refraction. Here we incident this ray at an angle of 30 degree. For the same angle, the ray is reflecting. That is why angle of incidence is equal to angle of reflection here. Whether this is true for all angles, let us see. That means, since we got angle of incidence is equal to angle of reflection for 30 degree, then whether it is possible for all other degrees, let's see by varying the position. See, now I am keeping it angle of incidence 60 degree. If I place it at 60 degree, angle of reflection we got 60. That is why angle of incidence is equal to the angle of reflection. Okay. So this is what we understood from this. Also see here. So here angle of refraction is 30 and nearest to 40. But angle of incidence is 60. So that is why what we can say is the angle of refraction is less than the angle of incidence. So this is what we can understand from this. And also you can see, since angle of incidence is greater than this angle of refraction, we can say this ray is towards this normal. See, as you increase angle, the angle of refraction doesn't vary much. So that is why what we can say, when the angle of incidence is greater than angle of refraction, then this refracted ray bends towards the normal. It will bends towards the normal. In this case, you can see the mediums also. Ray is traveling from this medium, rarer, to this medium, air medium, into the water medium. So in that case, ray is bending towards this medium. So this air medium can be considered as a rarer medium, and this water medium can be considered as a denser medium. So it doesn't mean that it is a mass density, which means this rarer and denser mediums are not equal to mass density of the medium. So see, this rarer and denser medium are determined by the ratio of the velocities of the medium. Okay. So here, since ray is traveling from rarer to denser, in that case angle of incidence is greater than the angle of refraction, so the ray is bending towards the normal. Then what will happen if the ray is traveling from this denser medium into the rarer medium? Let's see. See here, we are incidenting from this denser medium into the rarer. Now we are incidenting the light from water to air. That means we are incidenting the light from denser medium into the rarer medium. You can observe here, now the angle of incidence is 30, but angle of refraction is 40. Now the angle of refraction is greater than the angle of incidence. So in this case, ray is traveling from denser to rarer, and here you can see, as you increase angle, there is a more angle will covered by this refracted ray. So the refracted ray will bends away from the normal, which bends more away from the normal. So this happens when a ray travels from denser to rarer medium. So let us again see some of the phenomena here, some of the things. We can also see intensity. See this, see the intensity, 100% intensity, which is incident light. Refracted light have only 94 intensity. What about the remaining? It is here. It is 5.37 intensities reflecting there, and almost 95% of intensity is refracting here. So this is about in terms of intensity. See, as you vary, see here, when the source of light is incident at 90 degree, then it is passing along the surface of the two medium. See, it is grazing the surface of the two medium. Okay, and if you incident at an angle of 0, angle of incidence is 0, then you cannot see a refracted and a reflected light. So this is regarding this refraction of light.
As you learn from that animation, I draw the picture over here. So this is the incident ray, this is the refracted ray, incident ray, and this is the refracted ray. And these are the refractive indices of the two mediums. This is the one medium. We can call this as an air medium. We can say this as any other medium. It may be a water or glass or any other medium. So these two mediums have a different refractive indices or indices of a refraction. We can call that also. It can be called as a refractive indices or indices of a refraction. So you can directly get the meaning of that. So that indicators by what degree refraction takes place. So that is known as a refractive index. I am repeating, refractive index means a degree by which refraction takes place. At what amount of refraction takes place when a light is moving from one medium to another. So as I told you, this is experimented by Snell and he has given some laws. Let me write the law over here. First law status and the incident ray, and this is a normal and this is the refracted ray. So incident ray, refracted ray and the normal at the point of incidence lies in the same plane. See, I have drawn our plane here. Along this plane, we can see the three factors. One is incident ray, another one is a normal, another one is a refracted ray. So if a refraction is happening in any when a light travels from one medium to another, then all these things should lie in the same plane. So that is stated by Snell. So the incident ray, refracted ray, and normal at point of incidence lies in the same plane. You can clearly picturize here. I have drawn a plane over which we can see three elements. So second law states that this ratio of the sine of the angle of incidence, you know it already. This is angle of incidence, this is angle of refraction. So if we take the ratio of the sine of the angle of incidence to the sine of angle of refraction is a constant. Let me write. According to this, what we can write is it is a ratio of sine of the angle of incidence, sine of I, divided by sine of the angle of refraction, which gives a constant. As per the definition, we can write like this: sine I by sine R is equal to constant, and that constant can be written as n. N is called as a refractive index of the medium. I told you in the beginning, these are the refractive indexes. So here we have two mediums, N1 and N2, 1 and 2 mediums, and light is entering from N1 to N2. Light is entering from a medium of refractive index N1 to the medium of refractive index N2. So that's why we write as N21. So N21 is equal to sine by sine R. This N21 can also be written as N2 divided by N. Okay? Simplification of N2 by N1 is a N21. Or in other words, N21 can be split as a N2 by N1, which is also equal to sine I divided by sine R. So let us take these two results. Forget about this. So what happens? Sine I. So take the N1 here, take the sine R over to the RHS. Let's see what happens. So that we get n1 sin I equal to n2 sin I. So this nature should exhibit by light when a refraction takes place. So this is what stated by Snell. So he said that the ratio of angle of incidence, to the angle of refraction is constant for a given pair of medium. So this is the second law of refraction. This is the first law of refraction. So according to the second law, a condition must be satisfied, that is n1 sin I is equal to n2 sin R, or n21 is equal to sin I divided by sin R. So you can see here, light is entering from this medium into the another. Then what is the meaning of this refractive index n? I told it already. This tells, this is a number, it is an index, refractive index. Index means it is a number which tells by what degree a refraction taken place. So this is about refractive index. And here we will introduce the two more terms, which is called as a rarer and a dense. Here we, if we said that this is a air medium and this is a water medium or any other kind of medium, then this medium can be called as a rarer medium and this medium can be called as a denser medium. So this rarer medium and a denser medium should not be confused with the mass density. So we already know about the density. Density means it is a mass by volume. So what we said, denser medium and rarer medium are not related to that kind of a density. So this denser medium and a rarer medium are the ratios of the velocity of the light in the mediums. Refractive index of any medium is a ratio of velocity of light in any medium to the free space. So that is the what formula for refractive index, which is a general formula for refractive index. Yes. So here this medium can be called as a rarer medium. This medium can be called as a denser medium. So here the ray of light is entering from rarer to denser. As you saw from the your animation, when a ray of light is moving from rarer to denser, then the light ray, refracted ray, bends towards this norm. It will bend like this. Okay. And if the ray of light is traveling from denser to rarer, if the ray of light is traveling from denser to rarer, what you have observed is the refracted ray bends away from the norm. So away from the norm. So this was a observation we made in the animation. So let us study some more things about this. Here see, if you substitute the value for angle of incidence, this I, and if you substitute the value for R, you will get the value of this n21. If we say n21 is greater than 1, you will get a value, some value. If the n21 is, n is greater than 1, you will get a value which is greater than 1. Then what happens is, why this happens is, the R is less than I. What I can say is, this R is less than I, then you can get a value of n which is greater than 1. Let me write over here. These are the some basic knowledge you should have about this Snell's law. So first thing is, if n21 is greater than 1, you are getting a value n21 which is greater than 1. This happens when angle of incidence must be greater than this. Angle of incidence greater than r, then you will get n21 is greater than 1. So if this is the case, then the ray will bends towards 1 because I is greater than r. Okay, I is greater than r, so that ray bends towards normal, and ray will be traveling from rarer to denser medium. Okay. Here the ray will be traveling from rarer to denser, and also ray will bends towards the normal. So refracted ray, I should write. So refracted ray, I should mention this. So refracted ray bends towards normal. This is the one case. If you substitute value for I and r, and if you get n21 is less than 1, you got a value for n21 which is less than 1, then this happens when I is less than 1. If the I is less than r, this I is less than r is greater than I, then n is n will have less value because I am inversely proportional. So refracted ray, r is greater than right, r is greater than I. So refracted ray bends away from normal. And ray will be traveling from denser to rarer, denser to rarer medium. So this is what we can understand. And let us take one more case. If the ray of light is incident along this normal, so this is a normal, it is a perpendicular line, it should always draw to the point of incidence. Point of incidence means to the point where we are incidenting, at which we should draw normal. So this normal should be drawn at the point of incidence. So if this incident ray is incident along the direction of this normal, then what will happen? See, I will separately draw here. This is the direction of ray along the normal. Then what is angle of incidence and angle of refraction? We cannot see angle of incidence and angle of refraction. In that case, we cannot apply Snell's law. Snell's law cannot be applied when the ray of light is passing along the normal. So here, here the ray is moving from one medium to another. While moving so, the direction of the ray changes. See here, this is actually, it should pass like this, right? You saw it from the animation, it should pass like this, but it will bend, it will change its direction. So, the changing direction of a ray when it travels from one medium to another is called as a refraction. You should say like this, the changing direction of a ray when it passes from one medium to another. So this is known as a refraction. Yes. Let me write the definition for refraction. Changing direction of propagation of light when it travels from one medium to another medium. One medium into the another medium. So this is the definition for refraction. So let me tell you one more thing, which is a very important thing. So refraction, refraction index of any medium can be written in a simple formula, which is n is equal to c by. Okay, refraction index of medium. It is a ratio of the velocity of the light in a free space to the velocity of the light in the medium. So here we can introduce any kinds of a medium. For example, if we take on this, let's say the velocity of the light in the first medium is a v1. Let us say velocity of the light in the second medium is a v2, because these are the two different mediums. So if we do so, we can apply. See, in the n1 can be written as refractive index in the first medium can be written as C, which is a constant always. We should write C itself, and V becomes V1 here because it is in the first medium. N2 is equal to C by V. So what we should write, that is N2 by N1, which is equal to, we know that N21. So N2 by N1, N2 is equal to C by V2 here into, you should divide it, but go C. N1 is equal to V1 by C. So C cancels out. So V1 by V2. See, so this is another formula for refractive index. N21 is equal to V1 by V2. So we can also define the refractive index in the medium in terms of velocity of the light. So we can observe that there will be change in velocity of the light. Why it changes? Because the medium changes. It was traveling in one medium and it has to travel in another medium of another refractive index. So different medium have a different values of refractive indices. So that is why, since it has a different refractive indexes, it will bend. That is why its velocity varies. If it is traveling along the same direction, then the velocity of both the medium should be, the velocity of that light in both the medium should be same. So if the medium changes, then the refractive indices for different medium will also changes. Because of it, light will changes its direction. So this is about concept of refraction, and which is very important for